Hello students, in this video we are reviewing our physics quiz based on current electricity. Let's start. First question was about color coding. Register was given as colors were given red, violet, orange and silver. These four colors were given red, violet, orange and fourth color was given silver. So we know the tricks for this uh, that how to write the values. So we say B, Roy, Great, Britain, very good vibe, right? This sentence we remember. So look here. First color was given start from 0, 1, 2, 3, 4. It goes, right? Okay. First color was given red. Red means what? 2. Formula, also remember, formula like this one. Resistance is equal to what? RB 10 power C plus minus D percentage, right? So what is A here? First is what? Red color means 2. Then second color is given was violet. Violet means this becomes 7. So 27 into 10 power. C color is given what? Orange. Orange means 10 power what? 3 plus minus. Silver given means 10% error. So this you can also write 27 kilo ohm plus minus 10% error. So this is matching in the yes, second option. This answer is matching. So second is the correct answer for this question. Okay. Second question is about uh, potentiometer. So here they said ideal volt battery of 4 volt and resistance are connected in series. The primary circuit of potentiometer of length 1 meter and resistance given 5 ohm. The value of resistance are to give a potential difference of 5 millivolt across 10 centimeter of the wire. So here potential drop is given and the balancing length also given. They said 5 millivolt in 10 centimeter. So from this, what you can find? You can find potential gradient. Potential gradient, let's say x is what? Potential per unit length. Potential given 5 milli means 10 power minus 3 and length is given 10 centimeters 10 into 10 power minus 2. Oh, this will become 5 into 10 power what? Minus 2 volt per meter. It's the potential gradient. So what is unknown here actually? If you see the unknown thing is what? That resistance in series means rheostat or resistance in series unknown that we want to calculate. So potential gradient also equal to this formula, complete formula, EMF of the battery, RH plus RW plus internal resistance of the wire by what length. So internal resistance not given is okay. This they are asking rheostat, okay. So potential gradient is 5 into 10 power minus 2 is equal to EMF is given to you. So EMF was given 4 volt. Okay, 4 volt. RH you have to find resistance of the wire given 5 ohm. 5 ohm by length is given 1 meter. Okay, this 5 get cancelled here. Okay, so we're getting RH plus 5 is equal to 4 into 10 power minus 2 or this become 400. So RH should be equal to what? 400 minus 5, that's 395 ohm. That should be your correct answer and this answer is matching correctly in what? Third option. So C is the correct answer for this question. Okay. Moving to question number 3 and question number 3 says that a copper wire is traced towards 0.5% longer. The percentage change in electrical resistance volume remains constant. For this, I told you shortcut also. Again, you want to write, you can write resistance is what rho L by error question is given. But remember here that here length error given, area not given, so area you have to remove. What doesn't change volume? So you can multiply by L and divide by L. So that on top we get rho L square by down we get volume. Volume not changing, resistance not changing. So so resistivity not changing. So resistance is directly proportional to what L square. Del R by error you're writing 2 times of del L by L into what 100. So error in length is given. So 0.5 that becomes what 1%. This you can use shortcut also. I discussed shortcut in classroom also. Okay. So for this question, correct answer will be what your third option. Charlie will be the correct answer. 1% will be the error in the resistance of that. Okay, next question is about a uniform wire of length L, radius R has a resistance of 100 ohm. If it's recast into radius of R by 2, what is the new resistance? So this for this also I have discussed shortcut with you or general formula also can write. So now you know initial radius and final radius. Again, resistance what rho L by A, right? So now we know radius, so you have to remove length. You can multiply by area and divide by area. So we get this answer rho volume by area square. Volume constant, rho constant. So resistance inversely proportional area square. Area is again pi r square become inversely proportional resistance power 4. Right? Okay. Initial resistance given 100 ohm. New resistance given r. Right. Initial radius was given r. New radius given r by 2 and power 4. So this become 1 by 2 power 4 means what? 1 by 16. Correct. So that should be your answer. What is the answer? R which should be equal to what? 16 times of what? 100. So this becomes 1600 watt ohm. Correct? Okay. So for this question, correct answer will be what? Alpha. First option will be the correct answer. Moving on to question number 5. And question number 5 says that an electrical current is passed through the circuit containing two wires of the same material connected in parallel. If the length and radius ratio is given to us, they are asking what's the current passing through the wire. So they are in parallel given first. Parallel means voltage will be same. Potential will be what? Same. Correct. So resistance depends upon what we want to find actually current. Current is what? Potential by resistance. Potential is game. Same because these two are given in parallel. So current directly depends on resistance and resistance depends on what? Rho L by A. So let's calculate resistance is. So what is given to us? Length ratio and resistance radius ratio is given. So look, L by 1, L2 is given 4 by 3. Length ratio of these two resistance are given and radius ratio given as 2 by 3. So let's calculate their resistance ratio. R1 by R2 should be equal to what? Rho is a constant directly proportional to length. Length given 4 by 3 and inversely proportional to what? Area. Area means radius square. So it becomes 2 by 3 and square of this. Opposite we need. Okay. Inversely proportional. Okay. 4 4 goes here. So 3 goes here. 27. This become what? 3 only, right? 3 square. So resistance is coming what? Like R1 by R2 is coming 3. So current should be opposite of this because current and resistance are what? Inversely proportional. So I1 by I2 ratio should be equal to what? 1 by 3. So 1 by 3 should be matching in which option? Is matching in what? Second option, beta. Okay. Let's move on. So next question number 6 says that a resistance of wire R is bent into a form of square as shown in figure. The effective resistance between E and C point is what? Where E is the midpoint. So it's very simple. You have a wire of resistance R. You have turned this into a rectangle. Not a perfect square is given to you. Okay, like this way. Okay, yeah. So we have resistance R be turning into R. So every side should have R by 4, R by 4. Resistance also divided by equally R by 4, R by 4, right? Correct. Yes, four sides, so equal to. Now they are asking resistance between these 2 points. Which 2 points? Some E and what? Between E and C point. So they're writing this A, B, this is C and D, and this point they're calling E. So they're asking resistance between these 2 points. So look here, when you talk like resistance with these 2 points, you see just two branches have been parallel. Like from E to all these resistance is what in series. How much? Look here, R by 4 plus R by 4 plus R by 4, they are in series, plus this much. This resistance will be R by 8 because again half of this resistance also become R by 8. So plus R by what? 8. These all are in series. If you take 8 as LCM, then this goes, 4 goes 2 times, 4 goes 2 times, 6, 6 and 7. 7 by 8, this is the coming way resistance. Now this resistance and the resistance here, R by 8. Sorry, yes, they are what in parallel. So let's find net resistance Rp. You say 7 by 8 of R into R by 8 and addition of this simply becomes what? R by R, it becomes R only. Okay, so this get cancelled, so we're getting 7 by 64 times of the R, and this is matching correctly in what? Your second option. So second option the correct answer for this question. So this was the question number 6. Okay, now let's move to question number 7. Okay, this was question number 6. Question number 7 also similar question only. They said I have wire of resistance 18 ohm is bent into equilateral triangle. The resistance between any two triangle vertices is what? We have wire of resistance 18 ohm. We have turned this into a triangle, right? Three equal sides. They're asking what is the resistance between any 2 point, two terminals, right? So this becomes 6 ohm, that becomes 6 ohm, that becomes 6 ohm, equally divided, right? Three sides, equal resistance. So these two branches are in parallel. When you talk this point A and B, suppose these two resistance become so 12 ohm in series, this 6 and 6 are in series, and this 6 ohm. Now they are in parallel. So 12 into 6 upon 18, right? 6 goes 3 times, 3 goes 4 times. So 4 ohm should be the net resistance of this circuit, and this is matching in what your first option. So alpha should be the answer of question number what? 7. So alpha is the answer. Okay, moving to question number what? 8. In question number 8, they said that the current drawn from the 5-volt source will be. So you can see that it's very easy to see that the circuit 10. This is a Wheatstone bridge, right now. 10. Okay, let me draw if you want. So some resistances are given like this way, and it's an easy Wheatstone bridge given to us. So they're asking that what is the current flowing through battery, and 5-volt battery is given to here. This circuit is connected to a 5-volt battery, and resistances are given to us. How much resistance given? 5, 10, 20. So this is 5 ohm, this is 10 ohm, this is what 20 ohm. Okay, this is what 10 ohm, and last resistance is given as what 10 ohm. So watch carefully. This is a Wheatstone bridge. They are not in series and parallel. If you watch carefully, you will see that this is a P by Q. 10 by 20 is what 1 by 2. And R by S, 5 by 10. That also what 1 by 2. It means no current flows in this branch. You can remove this middle resistance. This is a galvanometer, right? So when you remove this, you see 10 ohm and 30 ohm, they are in what series? Become 30. 5 and 10, they becomes in what series? 15. So now they will be in parallel. So 30 into 15 upon 45. 45 goes what? 3 times. So this is giving net resistance giving us 10 ohm. They ask you what's the current flowing? Current is what? Potential is on 5 volt. Resistance is what? 10. So this becomes 0.5 ampere. That will be current flowing through the circuit. Right? Okay. Question number 9. So this is matching in what your second option. Beta is the correct answer for this question. Okay. Question number 9 we're doing. Again there is a circuit given. They say what is the current supplied by the circuit. So let me draw the circuit. A battery given to you. So circular circuit is given like this one. This is a battery here, 6 volt. And some resistances are given. How they are given? Look here, one resistance is given here. One resistance given here, and one resistance given what here. Three resistance are given to us. So no, four resistance are given. So one resistance given here also. This is given 3 ohm. Then other resistance 6 ohm, 1.5 ohm. This is given 6 ohm. This is given 1.5 ohm, and this is given what 2 ohm. So watch carefully. It's very easy. They asking what's the current flowing. Look here. This terminal and this terminal are same, and this terminal are same. So these two resistance, 2 ohm and 6 ohm, they are in parallel. 6 into 2 upon what 8. 2 goes 4 times. So we're getting 3 by 2 or 1.5. We have simplified these two branches. Now wrote one only. So now this and this will be what in series 1.5, 1.5. That becomes what 1.5 plus 1. They become series 3 ohm. Now this branch and that branch will be in parallel. So 3 into 3 upon 3 plus 3. That becomes what 1.5 ohm. So this is what your net resistance. Now they are asking what's the current flowing through the circuit. So current will be potential given 5, and this is given as 1.5, right? Okay. So that answer should be how much? So uh, approximately what should be the answer? So look here. No, battery is given actually 6 volt. I'm writing 5. 6. Okay. 6 by 1.5 is what? 4 ampere. So 4 ampere should be the correct answer. And this is given in the first option. Okay. Let's move to the next question. So we're talking now question number 10. And question number 10, a circuit is given. So let me draw this circuit first. So circuit is given like this. Okay, so this is the circuit and they're asking what's the potential difference between point A and what B. So potential difference between point A and B you have to calculate. So let's start calculating. Okay, watch carefully. Here currents are directions are unknown, so we have to choose any one direction of current. Okay, let's choose the direction of current. Okay, so what we'll do? So you choose a battery which has what high potential, highest potential, right? And we assume that current start from there and goes in all remaining branches. So there are two batteries are given equal. There's a 4 volt. There's also given 4 volt. Any one you can choose. There's no problem. If you direction of current is coming opposite, we'll get negative answer. So suppose I'm choosing this branch as what main battery. I said current I start from here. When current comes here, suppose some current goes here. Suppose I1 goes in this branch, then remaining current means I minus I1 will go in that branch. So this current comes here, again comes here. Okay, this current I1 is flowing through this branch, come here, and again they meet here, right? Okay, now we have to write Kirchhoff's law here. We take two loops. This is one loop, loop one. This is what second loop. You can go clockwise or anti-clockwise. Write the net voltage drop and find the current. Because you have to calculate potential difference between 2 points, means we need current in all branches. So let's write Kirchhoff's law. First, I'm writing for loop one. This is a loop one. Okay. I'm starting from any point. You can start. Suppose you start from this point. Okay. Let me change color so you can see it. So this point I'm starting. I'm going clockwise along this circuit and coming back here. I'm writing net voltage. I will draw in this way like that way. Okay. and I write the net voltage drop. So I'm starting from here. First, I got 2 volt battery. Voltage drop will be positive because jumping negative to positive terminal. Then I'm going to this 1 ohm resistance here. I'm going against the current. So voltage drop is called positive. So plus IR. I means what? I minus I1 and resistance what? 1 ohm only. Okay, plus. Then I'm going in this branch 2 ohm resistance. So again positive voltage drop 2I1. Then I'm getting battery. So minus 4. Then I'm coming here. I'm getting another this resistance. So plus I minus what? I1 all equal to what? 0. Okay, let's simplify this little. So how much we getting? I and I. We're getting 2I, I minus I1, minus I1 and plus 2I. So it becomes what? So I1, yes. 1 second. Okay, actually I wrote this wrong. This should be 2I only because this resistance I was talking. So current is what I. Okay, now okay, look here. So 2I and I, this become 4I. So 4I, then minus I1 that become minus 2I1. Minus 4 and what 2, that become what? Minus 2 all equal to what? 0. This is the equation 1. Now write the equation for second loop. Loop 2 we are talking. So let's write loop 2. You can start from any point. Let's start from point A. Go in this loop, same direction like clockwise only. Here you went clockwise, then next loop also you have to go clockwise. Okay. First I got this resistance 1 ohm. I'm going direction of current. So drop is called minus I1 into R. R is what? 1. Then I got this battery minus 4 volt. I'm jumping positive negative terminal. Again 1 ohm. So current minus I1. Okay. Because I'm going direction of current. Then I came here. Here I got plus 4 volt. I'm jumping positive to negative, negative to positive terminal. 2 ohm, I'm going direction of current. So drop is called minus 2I1, all equal to what? 0. This plus 4 will you get cancelled. So I, how much we getting? Okay, so I wrote it should be I. I'm writing again wrong. This resistance, current flowing is what? I. So I'm getting minus 2I, then minus 2I1 and plus 0 is equal to 0. There is nothing is there. Okay. Okay. So if you simplify this, I'm putting this equation together, both this equation. So 4I minus 2I1 minus 2 all equal to 0. You can add them minus plus plus. This get cancelled. So you're getting here now what? Minus 4 minus 6 minus 6 I1, and here you're getting what? Plus 2 all equal to 0. So I1 is obviously coming what? 1 by 3 ampere. This we needed. Okay. So this not I1, again I'm writing not I only. Okay. I. So current I we found as what? 1 by 3 ampere. Now you want to calculate potential drop from where to where? From A to B. Look in this branch. You can go directly A to B, you will get potential drop. So I'm writing here. Potential at point A is suppose VA. Then we going here, we got 2 ohm resistance and we going against the current, so drop is positive. 2 into current flowing is what? 1 by 3. Then we got minus 4 volt battery is equal to what? VB. So VA minus VB should be equal to what? 4 minus what? 2 by what? 3. So this become how much? 10 by 3 means 3.3 volts something. That should be the answer. And this answer is given in what? Your fourth option. So delta is the correct answer for this question. So simply we wrote Kirchhoff's law. That's all. Okay, question number 11. Look here, the simple circuit is given, and they said what is the current flowing to branch? What is I current when switch S is what? Close. So simple question only based on Kirchhoff's first law. So look here, all are given to us, and direction of current also given to us, more easy. So you said Kirchhoff's first law, that sum of all current is zero. Current coming in, I1 and I2 are coming, and they're going out toward I. So what is current I? Potential difference. Let's say potential here is what? V. Correct. Then look at 20 volt given. So 20 minus V by resistance 2 plus. And here become V minus what? 10 by what? 4. The current in this branch will be what? Okay. Here we should write like current is coming here. They're given all directions. So I should write this opposite. Okay. When not given, then we assume. So let me change. This is 10 minus V by what? 4. All equal to what? V minus 0 by what? 2. So you want to simplify this. So let's multiply this complete equation by what? 4. 4 you multiply, that becomes 40 minus 2V, and this becomes 10 minus V. this becomes what? 2V. Correct? Okay. So 40, that becomes 50, minus 2V minus V goes the other side becomes what? 5V. So V becomes what? 10 volt. Correct? Na? Okay. So potential at this junction potential is coming 10 volt. They are asking what's the current in this branch. So current in this branch obviously what? Potential difference means what? 10 minus 0 by what? 2. That becomes 5 ampere. So 5 ampere should be the current. That's given what your beta means second option is given correct answer. Okay. Moving to question number 12. And in question number 12, a circuit is given to us, and they're asking that what's the current, no current flowing through when 4 ohm resistor, potential difference between point A and D is what? So let me draw this circuit first. So watch carefully. They're asking potential difference 2 point, 1 point A here, 1 point what D here. And they're saying that no current flows through what? 4 ohm resistance. This is given to us. Okay. And they're asking that what is the potential difference between point A and D when no current flows through what? 4 ohm resistor. So watch carefully. We want to calculate potential from here to here. But you see that here this resistance is what? Unknown, right? Current also unknown. Two are unknown. So you don't need to write here Kirchhoff's laws here. Generally, when one thing is unknown, we write Kirchhoff's law. But you don't need to write here because look here. You want to find potential between A and D point, you don't need current because you go any path, like many paths are there. You can go by this path, then you need current in these resistances, right? You can go this path, then still you need this resistance. But if you go this path, look here, which path? You start from this point A and follow this path. You don't need anything. Follow this path. Yes, from here to here you go this path. You don't need current because current already given 0 this 4 ohm. There is only one resistance coming this path 4 ohm and current is given here 0. So let's start from point A, VA. Then I'm getting battery, so minus 9 volt. Then I'm getting this battery plus 4 volt. Then resistance, no voltage drop here is directly equal to what? VD. So VA minus VD is just what? 5 volt. This is a very simple equation. Actually, they gave all this to confuse you only. Okay. That's why solutions were very simple. So potential difference does not depend which path you follow. Here we have many paths. This is one path, then you can go this path, you can go down this path also. So you have to see which is easier path where the values are known. That path we can follow. Okay, right. Okay, so this was the question number 12. Now moving to question number 13. 13 is simple question. Here equation they said that Kirchhoff's law, that sum of all current is zero, and second law sum of all voltage drop is zero. They are based on what? So based on what? Conservation of charge and conservation of what? Energy. Correct? Na? So fourth option is correct answer. First law is based on conservation of charge and second law is based on conservation of energy. So we're moving to question number 14, which is interesting. Four bulbs are given of same power rating and same voltage. So question number 14 we're doing. Four bulbs are given of each power watt 100 watt and voltage rating given 220 volt. How they are connected is like this. So all are connected in parallel to a 220 volt supply. So here is a supply how much? 220 volt. And these four bulbs are connected in what? Parallel. So like these four bulbs are connected in parallel. So the question they are asking that an ammeter is connected somewhere. Where is connected? After 3 bulb. So it's connected what here at this point. Here's ammeter connected. They said what's the reading in ammeter? So let's simplify this circuit. First let's find net current. Then ammeter will read the current coming from these last three resistance, right? This is a main battery. Suppose positive terminal, negative terminal. Okay, current start from here. When current come here, there are four branches. 1, 2, 3, 4. All are in parallel of equal resistance. So let's find what's the resistance of each bulb first. Power is given, so power is what you know that V square by R. Let's find resistance. Resistance will be what? V square by P. V square means 220 into what? 220 by what? Power given 100. Okay, two zeros you can cancel. Just write that 22 into 22 down. That's the resistance. Okay. Now we have four resistances, right? All are connected in parallel. So what is net resistance of this circuit? Net resistance. Obviously 22 into 22 by what? 4. Yes or no? This you can write 11 into 11 if you want, right? 2 2 you can cancel. Oh, this is net resistance. 4 resistance of each this much value connected in parallel. What is net resistance divided by 4? Now what is net current? Net current will be what? Net voltage 220 by what? Net resistance 11 into what? 11. Correct. If you want to simplify this, you can simplify because this goes 20 times. So correct. So 20 by 11 ampere, that's the net current. Now net current is started here is what? I current is what? 20 upon 11. So this current will be divided equally among all branches. Like 1/4 goes here, 1/4 goes here, 1/4 goes, 1/4 goes. What is emitter read? Emitter will read current coming from this branch and that last three branch here, right? So current coming from last three means directly 3/4 of the total current right now into what 20 by what 11. 4 goes what 5 times. So it's coming 15 by 11 ampere. So if you see 15 by 11 ampere means answer should be something 1.35. Obviously yes, 1.35 ampere will be the answer. This is matching in what Charlie option, right? Yes, Charlie is matching. Okay, moving to question number 15 is about heating of metal. So well, resistance given 100 ohm given at what 100 degree, and as coefficient of resistance also given. They said resistance will become 200 at what temperature. So people confuse here about this question that initial resistance is given, initial not given, at some temperature is given to you. Okay, when temperature was 100 degrees Celsius, resistance was given 100 ohm. They said we want to make it 200 ohm. So what should be temperature? Temperature they are asking, and alpha is given to you 0.005. This is given to you. So be careful. The initial resistance not given. Keep R naught is not given. Just what resistance at some temperature is given to you. So your correct equation like this: RT is equal to R naught 1 plus alpha into R delta T. Right? Let's write two cases, right? First case you write. So the resistance at some temperature is given what 100 ohm. R naught we don't know, right? R naught 1 plus alpha given 0.0505 into what 100. This okay. So from here now you can calculate actual alpha. So 100 is equal to R naught. Okay. So if you watch carefully, this becomes how much? This becomes what? Zero point 0.5. Zero point 0.5 means become 1.5. So R naught is coming now 100 by what 1.5. This is your R naught. Or this you can also write 200 by 3 if you want, right? Simplified. Now write the second case, same equation for the second case. They said we want 200 ohm resistance. Initially we calculated is 200 by 3 now. 1 plus alpha we know 0.005. What should be del T? Okay. So now we can cancel. This goes 200, this becomes 3. 3 minus is 2. 2 is equal to 0.05 into what T. So T is coming 2 upon 0.05. Correct? So this become what 400 degrees Celsius. That should be the answer. So this is matching in what second option, beta option. This answer is what matching. Okay. Moving to question number 16. Question number 16 is about says that four resistance are given 15, 12, 4 and 10 are connected in cyclic order to form a beadstone bridge. The resistance that need to be connected in parallel with 10 ohm to balance the circuit is what? So four resistance given 15, 12, 4 and 10. Look here, this is your beadstone bridge suppose, and four resistance are given in any one order. You can write, you can start from anywhere, doesn't matter, answer should be correct always. So given this is suppose 15 ohm, this is what 12 ohm, this is given 4 ohm, and this is given 10 ohm. Then they said that what resistance I should connect with what 10 ohm. So that, and parallel I'm connecting here something resistance. Let's connect a resistance in parallel X resistance. So that this circuit becomes a balanced Wheatstone bridge. Balance means we know that P by Q should be equal to what R by S. P by Q should be what R by S. P by Q is 15 by 12. 15 by 12 should be equal to what? What is net resistance of this branch? 10x upon 10 plus x divided by what? 4. This P by Q is R by this complete R. Okay, by S. Okay, let's simplify this. If you divide them by what 3, this becomes 5 by 4 is equal to what 10x upon 10 plus x divided 4. 4 get cancelled. 5 goes what 2 times. We write 10 plus x is equal to what 2x, or x becomes what 10 ohm. So how much resistance we have to connect here? 10 ohm, so that the answer becomes same. So correct answer will be what delta here. Okay. Fourth option is the correct answer. 10 ohm resistance we have to connect. Okay. Okay. Now question number 17 is about potentiometer. They said in a potentiometer experiment, it is found that no current passes through galvanometer means balance circuit when terminal of the cells are connected across 52 centimeter of the potentiometer wire. So initially what happens, they said a cell was connected. This is 17 question. Cell was connected, balancing length is given. So only EMF is balanced, thus balancing length given L1 to you what? Something given how much? 52 centimeter. This is given. Now they said that a known resistance is connected. How much resistance? 5 ohm. Resistance given to what you 5 ohm. Connected in what? Parallel with that battery. right? Then the balancing length come toward 40 centimeters. So when you connect a resistance in parallel, then you know that terminal potential is balanced. So this balance against some balancing length L2 that's given 40 centimeters. So you simply want finding the internal resistance. So we know the formula is what, yeah, is what L1 upon L2 minus 1 into R. This is a formula, right? We can write E by V also. Yes. So simply is what 52 by 40 minus 1 into what resistance given what 5. So if you watch carefully, 52 minus 40, that becomes what 12, 12 by 40 into what 5. Okay. So this should be 60 by 40 means answer should become what around 1.5 ohm. That should be the resistance which is given what in your second option. Beta should be the correct answer for the given question. Okay. Beta. So beta is the answer of this question. Moving to question number 18. They gave a meter bridge. They said for the given meter bridge, find the value of unknown resistance. It's a very simple equation. Look here, known resistance is given 55 ohm, unknown resistance R, balancing length also given. So same formula, P by Q is equal to what R by S, right? P we write as balancing length 20 centimeter. Then Q we write 100 minus L, which is what 80. Okay. The known resistance is given to us what 55, unknown we have to find. Known is what 55, unknown is what X we have to find. So we can simplify this simply. This becomes 4 times. So X becomes what 55 into 4 means what 220 ohm. That should be a resistance. And this is given in what your second option. Right? Okay. Moving to question number 19. Again, a potentiometer question is given. They said a potentiometer experiment, the balancing length the cell adds is to what? 240 centimeter. Again, same internal resistance only, initially only cell connected. So balancing length L1 was given 240 centimeter. They said a resistance connected 2 ohm in what parallel with the cell. Correct, shunted. Then balancing length. Now terminal potential is balanced. Balancing length is given 120 centimeter. Again, they are asking what's the internal resistance. So internal resistance what L1 upon L2 minus 1 into what R. So it becomes what 240 by 120 minus 1 into what 2. This goes 2 times. What is the answer? 2 ohm itself answer coming, right? So 2 ohm should be the internal resistance, right? Okay, last question we're doing of this quiz. And last question is based on what? Galvanometer and ammeter. They said ammeter is there, it read up to what 1 ampere. Internal resistance given 0.1 ohm. To in this range 10 ampere was a shunt resistance required. So all are given. Initial current given how much? That's we call Ig 1 ampere given. Range we want to make is 10 ampere given. Galvanometer resistance given 0.81 ohm. They asking what is shunt resistance required. So you know the formula is what? Ig upon what? I minus Ig into capital G. So I is given 1 ampere, 10 minus 1 become 9 ampere into what 0.81. So divide here become 0.09 ohm. That should be the resistance, and that's given in what your delta option. So this was the solution of your quiz. Hope you understood all of this question. Okay. Thank you. Have a good day.